here with us today as we dive into the topic today of energy analysis in Revit. That is one of the approach to move towards net zero energy, right? So get ready for an engaging session, which will be filled with insights and practical takeaways. Let's just get started. So yeah, little bit about our organization. So we are now a part of global brand Arkans India, and we are one of the leading companies in AC industry dedicated to the integrated solutions. We specialize in providing key services with a focus to have a unique value addition and differentiations, right? As well as our commitment to excellence and innovation drives us to deliver exceptional results. So our clients across the pre-founded regions. So we have a very wide team which supports all of the services part, and we have 50 plus offices around serving onto the integrated solutions. So talking about the today's agenda, we are going to cover key insights and discussions around the net zero energy, emphasis emphasizing onto the building designs using Revit and its integrated workflows and how it is actually integrated with other solutions as well. So we have Kanchan with us, and she would be taking you to the design advanced brief, and then we'll follow into deep dive into further discussion points. The session will conclude with a Q&A segment, providing an opportunity for interactive dialogues for all of you and clarifying your questions. Over to you, Kanchan.
Thank you, Anurag. Good afternoon, everyone. I'll quickly brief everyone here about Design Advance. So, Design Advance is a competition now in its fourth year that is organized by Arkans. And this year's theme is Architecture of Assembly, Industrialized Construction for High-Rise Buildings. So, it is a competition for the students of architecture, design, planning, and civil engineering, or any allied disciplines. This year's theme focuses on revolutionizing the construction process using the uh, method of industrialized construction, particularly using prefabricated components. So it helps navigators challenges like unorganized labor, workmanship issues, site management, and pollution that is caused by construction activities. And how that is done, we'll just know after a few slides. So, coming to residential high rises or high rise apartments, all of us at this point might have seen them, might have been living in them. So, have you observed that there are repeating elements and identical layouts of units, as in the unit below you or the unit on uh, on top of you, they have the identical layout and they are just stacked on top of each other. The staircases, the railings, the facade, the balconies, toilets, these are often designed as repeating elements and are often used from often designed as one and just repeated everywhere. Due to the scale of the project and the limitations of conventional construction process, these projects, the high-rise buildings, they are going to take a long time to be completed and to be occupied. But how is it that we can save time, effort, expenses, and resources while designing these buildings? How can we standardize these elements like balconies or railings or say washrooms, doors and windows, and like even walls? How can we standardize them and maybe mass produce them to assemble later? So that's where industrialized construction comes in. And so what happens with prefabricated construction is the foundation will be laid using only the conventional method of construction, but the superstructure components like the walls, floors, doors and windows, etc., they can be produced in a factory and then they will be transported to the site and they're assembled later. So the first step in this process is standardizing all these elements and designing them according to requirements, and then these elements will be produced in the factory in however numbers you require them. Then the prefabricated elements will be transported to the designated site and the building elements will be assembled there. What can be prefabricated is a long list of elements actually. So fire stairs, elevators, plumbing, cooling, ventilation systems, these all can be prefabricated. Complex elements which might be difficult to achieve using manual labor or other methods, they can also be prefabricated for their accuracy. Then the walls and the floor panels and the doors and windows and toilets, kitchenettes, etc., all of these can be prefabricated. So what you'll have is originally the foundation will be laid using conventional construction, and all of the superstructure elements, more or less, you can prefabricate and assemble on the site. Here is our first case study, which is called 10 degrees in London, United Kingdom. You can see the interplay of these volumes, and the facade itself has been prefabricated, and it is the shape is repeating that you can observe in this picture itself. And let's look at it a little more closely. So it was completed in a 39-month timeline, which is actually a big feat for a project that is this size, right? From concept sketch to handover. That's a very short timeline. Then, compared to the conventional methods of construction, this was a 67% reduced carbon emission. That's also a very good feat. Then significant reduction in waste and a better quality control was achieved using prefabricated construction. Now you might wonder, how did they do it? So what they did was they extensively used virtual reality and 3D printing methods to make prototypes, like models on a smaller scale, and worked out what will work, what won't work, and what we should do at a larger scale. And then these prefabricated components for the actual building, they were manufactured off-site and assembled on top of each other. Another case study that you can check out for yourself is the De Quickeridge Apartments in Utrecht, the Netherlands. So here the kitchens, bathrooms, stairs and facade, they were all prefabricated and placed. It's a very highly standardized and rationalized group of buildings, and there are only two types of homes. But you can also notice here what they have done with the facade. So interestingly, with a lot of colors and shapes and a lot of geometry, right? So it doesn't mean that you have to design boxes when you're prefabricating. You can also be really creative. So the task for you for the purpose of design advanced competition would be to design a high-rise residential building or a building complex using industrialized construction with prefabricated building components. So the first step for you would be to understand industrialized construction and prefabrication of building components to create sustainable and inclusive and accessible spaces. And the second thing that you would need to do is explore some suitable construction materials, because not all of the conventional methods that we use for construction can be applied here. So you might also have to think of and to research about some newer materials, and you really have to push your creative boundaries. You should maximize the use of industrial elements in the design and the execution of the structure. And of course, you first have to standardize all the repeating elements so you can visualize how these can be stacked on top of each other. Here are the competition guidelines. So beginning with the site selection, your site should be an urban site in a tier 1 or tier 2 city with the following guidelines. The site area should be 5 to 12 acres, and the minimum FAR that you should think about achieving is an FAR of 3. Then the green cover should be at least 15% of the site area, and you should follow the local bylaws. In case you can't access the local bylaws, or they are not available to you, you can use the National Building Code in the absence. At least 50% of your design should be constructed using industrialized construction, prefabricated components, partially or entirely. And you can show these details on 1 to 2 sheets, like which components that you've chosen and why you've chosen them, and how has it impacted your design process, and how it will impact the actual life of the building. Then here are some design considerations for you: how well you integrate the industrialized construction process, how well done your and in depth your research is into this process, how sustainable is your design, how your design promotes well-being, and how creative have you been with the process, right? Here are some important dates. So the registrations will close on October 7th, and the submissions will close on October 17th. And the competition is open to all undergraduate and postgraduate students of architecture, planning, civil engineering, and design globally. And those graduating from these courses in 2024, they can also participate in Designaddvance. A maximum of 3 members per team are allowed, and you can also make teams with students from different batches in your college, or even with your friends from different colleges, right? Just remember, you'll have to have one architecture student in your team. Some frequently asked questions just before we close this briefing. Is there any registration fee for the competition or the workshops? No, both are absolutely free for you. There is no registration fee. There is no registration fee for the competition or the workshops. Can postgraduate students take part in the competition? Of course, they can. UG and PG students of architecture, design, civil engineering, and planning disciplines, they are welcome to participate in the competition. Can the team members be from different colleges? Yes, inter-college and inter-batch teams are allowed for the competition. In absence of local bylaws, which standards should you use? We saw before, National Building Code is to be followed in case the local bylaws are not available to you. Can we choose a site on our own? Yes, of course, absolutely. You can choose a site on your own. Just remember that it has to be a urban site in a tier 1 or tier 2 city, and the area should be between 5 to 12 acres. And can we define our area programs? Of course, you can choose the functions and the distribution of spaces that are allotted for these different functions according to whatever your site demands and needs. So closing the briefing, here is the QR code that you can register, that you can scan directly to register for Designaddvance. And we hope you participate in the competition. Thank you so much.
Thank you so much, Kanchan, for the brief. So we'll be beginning with the further key points now. And firstly, uh, so it would be something like why we are here to discuss this net zero energy, right? Then we will be looking at energy analysis in using the Revit part, utilizing the passive and active design measures as well onto the designs portions. Then we will be performing shadow analysis as well as an illumination based out of Autodesk Revit. Then we'll have solar analysis, which would be using a plugin source that Autodesk has. And then we'll look onto the energy model analysis, which has been created for transporting all the data to the Autodesk Insight. Right. So why are we talking actually about the net zero energy? So as you all know that due to the growing needs and to address the impacts like climate change, reduction in carbon emissions, and to promote sustainability, which is one of the most important factors. So that's why we are going to discuss on net zero energy. So talking more about the sustainable part where each one aspects like not net zero energy is basically a part of sustainable designs. So what actually is sustainable in deeper senses, like when we stay with the longer time duration of particular things and to make them to give particular ROI at the end and to survive for the several decades further. in which we have invested upon. So that's how the self-sufficiency and sustainability comes into play. So major factors that are concerned with respect to it is like how we can utilize cost savings onto our buildings, how we can make our designs more impactful by generating energy efficiencies within our designs, whether it's about facades, whether it's about utilizing those spaces, utilizing daylightnings, and so on. So, and the most important part is, are we utilizing the renewable sources of energy, which are actually available to us in plenty? So that's all are the three factors that contributes towards the sustainable portions. So talking about the energy analysis, so the first thing that comes to our mind is how green is our building? So whether our building is green or not, and green has been determined with the help of how much impact does it have onto its environment. So we are going to look all these features and what is a building life cost cycle that is associated within a project. Are we going to achieve it, and are we going to have a return on investment onto the particular part at the end of a life cycle, at the end of a project execution part? So this is all with respect to the energy analysis that we are going to look how is Revit going to help us in all these situations. Right, so talking about the part where we are dealing more with energy analysis methodology. So in the earlier parts, we usually have this static calculations which were being done manually, right? We take out the materials, their specifications, and we try to estimate out of it, like on the basis of material, how much the material will emit or will contribute to the environment in a safer way, or will also have a destructive feature on the other hand. So this, and we usually prepares the method technologies like using the Excels and other sort of stuff, which was quite time taking and costly. And if we utilize the interoperability or the solutions between the integrated workflows where multiple software solutions are involved, then it comes basically with the interoperability part. So in order to make your efforts less and reduce your efforts and manual tasks, one should have a greater connectivity in terms of other aspects or other solutions that you are using. So whether it's from the conceptual stage of design to its end, so like for just talking about the integrated part, so in the Autodesk solutions, we have a number of solutions which are integrated using the Autodesk central part. Like, so if I need to have a conceptual massing at my end, I would start with the Format Pro, and then I will bring all the former part where I have to have a conceptual analysis. How much is the sun hitting onto my building? How can I utilize those surfaces? What will be actual wall window to the wall ratios? So I can manage all those things at a conceptual stages using one of the solutions, right? Then I can take that solution particularly on the Revit for detailed designing. Then particularly after detailed designing, Revit has been very well integrated with Twinmotion for visualization, as well as on the same part, it has been involved with Naviswork to have a clash detection part. So this is how a profounded integrated workflow system works. And that's how it will make our work more easier and more better uh, in optimizing our own tasks. Talking about the net zero approach. So in short, if I just talk, so it is the total energy that is being used on the to the building onto the annual basis. So how much you are consuming the energy is one part of it. And the other part of it is how much you are utilizing the renewable sources within your premises, whether an active portion or an solar passive portion to it. So once that means once we have taken those energy buildings on the annual basis, how much our building is consuming, then we have to locate the same sort of things or the renewable sources to generate the same source of energy for us at the same time, which can be utilized onto the building for its daily usages. If extra is also needed, so now government has also launched certain programs in which you can transfer those energies onto the power stations directly, where you will get something out of it as a prices as well. So that's how this is not only about a high-rise building or a bigger scale building. So this is more related to even small designings that each and every individual can contribute to. So that's how India is going to be transformed into a net zero approach by developing small dwelling units, which even have the solar units or the utilization of these renewable sources. And now talking about the strategic comparisons, that is between an active sources and the passive sources. Right. So active sources are something which are more in terms of utilizing cost, which has in certain factors of cost associated with it. Eventually, passive also has a cost associated with it, but it's in low amount. Uh, and active do needs a high sort of maintenance, and their installation they have to look after in each and every phases of design. So where an external sources comes into play, that's the active design. So we try to not use those actives much, but we can use all those traditional sort of methods that been developed with the low cost housings or with the better environment facilities using the materials like mud. So we can all move on to the passive design strategies, which will contribute to us in a longer term, I would say. So it has a less initial cost associated with any of the factors. Then it takes a less maintenance as well, and is eco-friendly, environment friendly, and is much more aesthetic appealing in terms of utilizing those spaces, facades, or any of these sorts of material. Right. So now it's a part how Revit can help us in energy analysis. So here's a small video for you all guys. Please look after.
Discover Revit Systems Analysis, integrated analysis and modeling, better design and performance. Use architectural models at any level of detail and completeness to quickly create accurate analytical geometry. This is especially valuable for enabling systems analysis from the earliest stages of design, staying in sync with architectural development. This is the same analytical model used by Autodesk Insight, which now includes extended climate data, envelope material thermal, and building space type data. Capture HVAC system design intent with a simple sketch tool, attaching smart system objects from an extensive range of types to define which systems serve what regions of the building. This forms the basis for analysis, as well as downstream coordination, documentation, and detailing. Use Revit views and schedules to validate the model before analysis, and explore model outputs in graphical and tabular form. Powered by Energy Plus and built using the Open Studio programming interface, Revit Systems Analysis ensures high trust and confidence and provides total transparency into how analysis is run and, critically, the ability to create custom workflows. This opens the door to much greater analytical physical workflow automation and whole building and system design optimization. Discover Revit Systems Analysis, integrated analysis and modeling, better design and performance.
Right, so that was a part how Revit can help you in utilizing the energy analysis part. So from the conceptual stages of a design, you can have those conceptual masses developed out of form where you can check how what is the optimization the energy is getting, and how optimized you can make your buildings by performing a certain sort of design analysis based out of BIM model. So coming back to the part how it will help you in early stages of designs. So first is like you have an integrated analysis entire model of BIM where multiple domains are coordinated together, where if you just take them onto the insight portion, it will give you or multiple design options and strategies, and how to compare them on the basis of performances. So you can play with those simulations again. Thirdly, it will give you an impact of on how the things are going to perform onto the building aspects of it, whether it has been associated with your forms, whether it has been associated with your openings, lightning, power densities, and so on. Right. So in this way, as you can see onto the right hand side, it can give you a capture sort of area, whether onto the interior designing part or to an external facade. So how much light is going to incident onto your surfaces and how you need to utilize them according to the design sources, whether you're talking about the summer solstice, winter solstice, or certain other factors, or how a building will perform during its winter season as well as onto the summer season. So you can optimize on the basis of how much radiations according to the locations you are getting onto the building surfaces. Then you can plan them accordingly, whether to install solar panels onto the facades or not, whether you need to optimize them using onto the roofs or some other parts of design which can be used as a passive designs. So in this way, it gives you an retarded images, which will help you out in performing your designs much better in terms of performances. Right, talking about the studies which Revit can perform initially is your solar load and radiation calculation, which can be done. And then we have sun and shadow analysis, which we are going to look in later part today. Then illumination is one of the same part which solar analysis does. So it's both of them terminologies are same, but we have different methods of doing it in Revit, whether using plugins or whether utilizing the cloud rendering sort of data. And then we can have heating and load calculations as well. So that's basically the part of MEP section. So we'll be dealing more with the architectural portions today. So the first portion that comes whenever we move on to the interface is like how we need to utilize the sun settings. So first thing is to set up your own locations, and then you should have a particular timings where you need to judge onto the basis of solar and shadow analysis where to locate and its advanced settings. So whatsoever, whether you need an still sort of settings, whether you need a single day solar analysis, whether you need a sort of multiple day solar analysis. So all those things can be predicted onto Revit. Right, so in this onto the right hand side, you can see very clearly we have four default solar studies which has been available onto Revit. One is still talking about still it's similar. It takes a single time of a particular day. Talking about complete single day, you can set your initial timings from where to where you need to judge a particular building upon. Similarly, with multi-day aspects, you can have multiple days study with multiple time orders. Right, so talking predefinedly, Revit takes an initial default locking, which is usually you will find on the USA sites, Boston and all. So you can set them according to your location and then can work upon easily. And similarly is the case with the shadow analysis. So here's a small video on solar and solar studies and how to develop solar studies, how to take an application out of solar studies. So we'll play this for a while and then we'll move on to the live demo part using the high-rise buildings that we have. So now the first part of it is like you need to have your solar settings done or the sun settings. So whether you need to move a single day element, multi-day, that's your choice to work upon, so that you can share those data particularly to your vendors as well on the other end when you're working on a collaborative mode. Then you have to pull your sun shades on and your shadows also, you need to activate it. Then developing the solar study out of it. You can set out the keyframes and then you can judge what impact does this particular sun settings has onto the buildings. as well as how this building will have an impact on the other buildings if you have surrounding developed onto your Revit model as well. Right, so we'll just take you directly onto the interface now. So here we have a multi-residential apartment, like which has an sort of 4 family or of 2 BHK sort of plan onto the 4 aspects of it. And now we are going to have certain studies developed out of this model, right? So there are certain elements which has been linked together. So one was my architectural model and the other was my structural model. So they are being linked together. And we have certain surroundings which has been developed using your massing forms or a simple wall to roof ratios, basically, right? So a simple common elements have been used in short, if I say. So the first thing to come with is to set up your own location. So under the manage tab, I have to set my own initial locations. There are 2 things out of it. Once you choose out the location, just for an example, if I say that's Delhi, India. So I have this location. I can go and click onto this, and then I can zoom to have a precise location. Even you have a precise latitude and longitude, you can just copy paste over here onto this area. So it will take you directly onto the particular locations. Likewise, if I just ping it over here onto Delhi, it has certain latitude and longitude associated with a particular place. Then you can choose a particular, I would say, the weather stations which have been applicable on onto the particular location sites. So there are certain weather stations you can pick out to them and go on. Okay. So once this is done, this was the most initial part where you can set your own locations within a project. But initially, if you're working with architectural and structural models separately, you need to have a shared coordinates as well as a shared location option on. Right. Then the second part of it is I need to turn on my sun path location according to the specified design date and time. So this is something. And then I can also on my shadows. Right. And now moving on to the particular sun settings. So the first thing is like we have to proceed with a stilt image. So you can see now the location has been of Delhi itself, which has been already picked. And you can change your dates and timings according to your need. For suppose that's 29th 9 2024 and the particular timing. So it will detect your entire shadow analysis onto the basis of single timings. And then which plane you need to have, and then you can have a save settings or further presets associated with it. So it's in session which we are developing. Certainly for the others, you have other options in presets like summer solstice, which is the longest daytime, 21 of June, where sun is at the top, days are longer, nights are shorter. Similarly for the winter solstice, where sun is at the maximum tilt with respect to earth is at the maximum tilt with respect to its sun. So all those predefined settings which you require in your analysis of your buildings, you can choose them accordingly. Similarly, if I just move with the single day, so we'll be performing for the single day and multiple day. So that's the today's location, that's the location, that's the daytime, that's 29/2024, and I'm specifying it from 11 of morning, say, to I need this study to be till 4 of evening as per my Delhi location. So then you have other option whether you need to have sunrise to sunset. So it will have a particularly defined time zones, that is from the morning 6 to the evening 6. If you don't need those long sort of studies, you just need the targeted values, you can put those timings accordingly. Other thing is you can see we have frames. So frames have something like how long the video should be. So if you have the time interval within 1 hour, so it has in 6 frames. The video would be quite short to play. If I just have 45 minutes, it would have 7 frames. 30, it would have 11 frames. So now, depending on the time intervals frame are getting executed, and the frames detect how long or how precise the videos you need it to be. So for a while, I would just keep it as 30 with 11 frames and will apply onto the location. Once done that, now you can see we have a predefined sun sources where you can see how it has an impact if I moved it to 11:30. So shadows have turned around, right? So in this way, you can see what impact your building will have onto the surroundings. At the same time, what these buildings will have an impact onto your building, depending on how the sun is moving from east to west. So now we'll develop a small solar study out of it. For solar study, you can just go on to this option itself. After setting the sun settings, go on to solar study part. So once you choose that, all the portions which has been activated, you can utilize all those assets, right? So we have chosen a single day study. So here we are moving with single day. Eventually, you have the presets in session which you have set it. You can go with 1 day solar study as well, right? So it's for the single day which you have set it. So it turns out onto in single day likewise. So right now it's taking 29, 11:30, so on, and you can play the preview accordingly. So once you do that, you can see how a building is having an impact onto its surrounding. And then you have the other options to extract this particular animation in the form of videos as well. So you can hit to those targets and can share these particular presets file to your vendors or whomsoever as a team member is working within your project. You can share with those things as well with the key markups. So it's very simple, like moving on to export option. And then we have images and animation. We have an option of solar study. So again, now we need all the frames or a frame range that's depend on you. Now it says to start and end, we have 10 different frames, and per frame has per second, which is 15. So the video timing would be of just 1 second. 10 is the keyframe that we have set it, 10 to 11, which will be divided by 15. So it will be a single second video. Similarly, if I need to have 15 minutes video, I will set the per frames key second as 1. And then if I need to include time and date, I can do that as well. So I will just have it as V03 onto my desktop, and I can save it. Once this has been done, it will have an uncompressed video versions, which you can see onto your preview as well. And your video is also getting exported at the very same time. Right. So in this way, you can analyze the impact of shadows onto your surroundings and onto your buildings as well. And if I just talk about a multi-dimensional or a multi-day analysis that you need, that can also be achieved using Revit as well. So right now we have just specified a single day. So similarly, we need to move on. First part was very same, like we have to set up your own locations. Then moving on to other sort of study. So we'll have some settings for other sort of study, let's say multi-day settings, right? So same location. Now I need it from 20th of September 2024 to say 27, a week of study, right? And the timings should be from same, let's say from 11 onwards to 3. And now you can see again, you have an 1 hour of interval with keyframes as 40. You can initiate them according to your uses. Well, keep it for a while, like for a day itself. So the keyframes get reduced somehow, and can press it on OK. So once this is done, you can see it has an particular 7 days lapping over here. You can choose multi-day, again a multi-day settings. You can go with the further settings over here, which was similar. You can check those settings again back, right? And if I just play for this one, so you can see this is how it acts. So this has been specialized particularly with respect to 29/2024, which is 11 a.m. onwards, right? Need to have multi-days. Again, you have to go with those settings in frame. So then it will pick up your entire day's location likewise. Right, so it has right now, we have to stagger that from the sun settings as well now because it has begun 2010 onwards. So you can export those sort of videos as well. So for the multiple days as well, you can predict how your shadows are going to work across. So I have a very same video which has been exported in the form of multiple days shadows. We'll be just showcasing you that in a while. So that's it, right? So we'll just take you back. So this is one of the videos that we have fetched out with the same building sources, but with the multiple time settings. Okay, so you have from the September 19, 2024, from 11 onwards to 26th or 27th of September. So you can initially see how the time changes over here with particular things and how the shadows will have an impact onto the buildings. I'll play this. So now it's September 20 from 21. Then 22, similarly with 23. Right, so in this way out, you can easily analyze how your things are going to be with respect to the buildings and its surrounding as well. So we'll now just take you directly onto the interface again, and we'll run a sort of illumination analysis, I would say, so that we can predict how much is the radiations that are getting incidented onto our surfaces of building. And we can also replicate that, or we can also analyze that using a plugin which has been available to us in Revit, which is a solar and illuminance, both of them. So this is our model. And so we have seen how and shadow has an impact. Now we will be looking at how a solar radiations would have an impact onto the building and how we can optimize those radiations or solar things onto our designs to make them achieve net zero energy buildings as well. Right. So we'll be going on to view and we'll be going on rendering cloud option. So now the first part of it is like you have to see the 3D view aspect which has been activated. So that's the simple 3D view, one of the views I do have on my project. So I will select, otherwise if you have multiple views, whether it's related to interiors or exteriors, you can choose them by dragging this option, by drop downing this option. Right now you need an still image, standard image, or median image. So that again works on the basis of flex tokens. So if you need to have higher quality, more predefined factors, you need to purchase those flex tokens in order to make it work predefinedly as you need. right? So I'm choosing right now for the standard. Other options are final and standard. Image size can be medium, and what sort of study do I need to run is illuminance, right? So the output type would be illuminance based out our 3D view, and the image size is medium. Now, as already predefined, we have those locations already set up with 24 today's date 29 in 2024. So it's been already taken once you set up those locations, right? You can also use this option for use the data from the view if this particular view is associated with those things which has been implicated onto the solar diagrams. So that will take it automatically from here. Talking about the solar sky model, so this is something which is not associated with anything so far. So like it has predefined default settings with 6 of the skies that are available. But if I choose any of the other skies, you see these values, which is DNI and DHI, doesn't gets updated by using those skies as well. So that means that particular sky is somehow not related to these values. Otherwise, if I would have chosen the other sky portion, it would have automatically taken a certain range of DNI and DHI. So what exactly are these DHI and DNI? So these are termed as direct normal irradiance and the diffused horizontal irradiance. That means how much energy is falling onto your surface, you will be able to know that. And that's particularly in a unit which is known as kilowatt hour per meter square. So that's the amount of energy that has been getting onto the surface of per square meter unit, right? So you can decide those ranges accordingly. Similarly, over here, it's divided by 1000, that's watt per meter square uh, area without any R involved in it. So if I just say in normal basis, a surface is being incidented with a light of 9 kilowatt per hour per meter square. That means that particular surface is going to have an illumination till 9 long hours, so that you can analyze those things like this is particular location for the solar panels to install because this is getting maximum radiation. So if I just install 2 of the units within, that will work for my entire building. So this is how its application varies. So I will just go by the default setting itself, that's pre, and I won't be changing it for now, and we'll just go with rendering option. So this will take a while, and so now you can see I have my ID which has been popped up, that the rendering has been started. And once the rendering is done, it will notify onto your mails, or you will have this icon stopped here itself, accounting that the rendering has been finished, right? So if I need to, so I had in previous presets which has been defined by these buildings, so I can showcase you to those things rather than waiting for this thing to happen. And just I would be going on to my view gallery. Under the routing light, I have this render gallery option. So this will take me directly to the portal of cloud rendering, where I just need to log in my credentials and just look at the renderings, how it has an impact onto my building surfaces. So this is the project, and the third rendering is in progress. Other two belonging to the same projects has been done already. So we will be going through that 1 and 2 option of it. Right, so if I filter it accordingly, all rendering 3 and 3, and I have set it those same location, and now here you can utilize, so you will get this sort of diagram over here where you can see onto the right hand side we have the labels onto the basis of energy that has been falling onto the surfaces. So this surface which belongs is quite having a lower sort of energy illuminate in terms of illumines, and onto the other aspects like roof, if you see, and onto the right hand side of a building. So these are being maximally exposed to the solar radiations. So now we can plan onto our building designs as well, like how to utilize those surfaces areas and how to plan for certain units to be placed to generate same alternative sources of energy and develop the same ROIs at the end of a project or for the coming future generation or the years to go, so that the building can be maintained automatically with the help of renewable sources, right? Similarly, you can see on to this end that the building is having a particular shade onto this particular mass aspects. So this predicts for the particular time, like we cannot install those panels onto the roof of this building somehow. So we need to plan either onto the vertical facades or some other alternatives to it, right? So in this sort of analysis it gives you. Similarly, there was other thing with the same locations. So you can see this model has been enlightened completely. Only the back portion has been left. So a particular range which is falling, you can see how this works basically. And you can utilize them onto your analysis part as well. Coming back to one more portion. So this is what we have seen how this will have an impact on. Now there is another part to it which deals with the uh, plugin which is for the solar and illuminance. So if I just move on to the options of analyze, you can see this has been inactivated because right now I'm onto my solar studies. So once I come back by pressing escape, I would have this plugin activated, right? So this also has in certain predefined settings, but it won't work on this integrated surfaces because it needs the elements to have been highlighted. So here the architectural and structural models are being linked together, and then we are performing the analysis out of it. So this won't work because it's acting as an linked entity as well as a single group. So for this, I should have a particular domain file and where I can check how this solar will be acting, solar analysis would be acting onto the buildings as well. So I will just open my architectural model itself. So it says, I cannot because the link has been embedded onto this. Fine. So we'll take a while. So we'll perform that particular solar part onto our interface using a plugin option. So now we have seen like the first facade is receiving a quite low sort of solar radiations, but onto the other sides, the building is actually getting illuminance, you would say, at the direct solar radiations. So here's the architectural model. So there were multiple models linked together onto the same file. So this is one of such. So if spaces has been defined, you can choose those options accordingly. And it's about only the massing or certain sort of areas. We can also check that as well. I'll be going on to analyze tab, and under this we have this solar option to get activated, right? Now it asks, so first thing was to have your so right now I'm not defining the location onto this particular file. Okay, so let's see how it also helps you in updating those datas directly rather than going on to the process again and again. So here, if there are two other options, either you need masses, surfaces of exteriors, and your user selection. So you can go by any of the options. Similarly is the date, time, and settings. So right now it's pre-default, and 0 is the meter square area which has been selected, and insolation is something, again, the number of rays that are going to incident onto your surface. So let's check this particular value which I was talking about, kilowatt per hour per meter square area, right? So I will just pick up the certain surfaces. I will go with this option, right? So we'll have just 2 to 3 surfaces to have for the analysis. Really, let me go with certain other things like this. So that's okay for me right now. So in order to depict how this works basically, then I can go on to the option of finish. Once I do that, according to the predefined location, which was already there into the Revit, now it says the study is taking place for 264 meters square of an area, which we have selected so far. And now we have to depict how much is the amount of solar rays that are falling onto this particular surfaces. I can update it, right? So once you do that, depending on the scale, it will show the cumulative insolation that works onto the particular facade area. So we were knowing that this particular thing was having the least of what we call the solar radiations onto according to the locations, but right now I haven't selected the location so far. So though it's saying it's like 134972 kilowatt of energy this particular surface is receiving, and out of the area it has, so can be divided. So it has an 512 kilowatt per meter square of radiations that are being incidented onto the surface. So that's quite high, right? And if I just see this graph over here, so it gives me the lower value and the most, so it's a mean, which is 400, 0, and the upper value out of it, where we have to try to bring those portions onto the green areas for developing those optimum solutions accordingly, according to the designs. Right. So now if I just try to signify this with the help of Delhi location itself, so you can see, you might see all the changes that take place within this graph as well. We'll be going on to location again. And under the location, I will again type Delhi, India. And this is something, again, we'll do the same sort of process for this file as well. Choosing out the weather station, and so once this location has been updated, I would again just update my entire process. So now you can see the enhanced results occur something like this according to our location. So this is the range where we have to bring it for the green part, and that's the maximum solar radiations, which is for the entire surface area that we have selected so far. So this is how a particular thing in meter square, and the energy in kilowatt gives you an 813. So that's quite high. So that means according to this particular things, you need to have your applications accordingly by keeping those all those points together. So we'll be back onto this. So this is what we have discussed so far, like what illumination analysis is and how we can extract those informations using Revit as a portion. So that's quite simple thing. Like if I just talk about the illuminance onto the theoretical aspects of it, it's the amount of light that incidented onto the surface per meter square of an area. Similarly is the illuminance which gets reflected. So you can see this figure, the source of light is candle. It's falling on the surface, that becomes illuminance per meter square. When it's emitted and reaches to your eye, becomes luminance in candela per meter square of an area. So these are certain specifications which has been associated particularly with the certain sort of spaces that has been divided into certain zones where building lies so far. So you can go with those NBC codes as well for having a standardization according to a particular space or zones. This is all what we have seen. So if you need to develop certain interiors as well, where the light is reaching its maximum and where lights are falling short, so you can have those things within the interior portion as well. So similarly, you have to set a 3D view for the interior part by setting your cameras, and then again going on to cloud rendering option for utilizing those things according to your own locations. So that can be done in two of the aspects. Like if you need the things in lux, that will give you an illumination onto the basis of lux or foot candela. There are two predefined options that are applicable with Revit. Here's a small video for the same process.
Once the model is opened, open the 03-floor public-day rendering view. Next, we'll create an illuminance rendering for this view. From the View tab, select Render in the Cloud. If prompted, select Continue in the dialog box that welcomes you to rendering in the cloud and summarizes the steps needed for illuminance rendering. On the next screen, select a 3D view created in the project for the illuminance rendering. Choose the 03-floor public-day rendering view. You can select one or multiple views to render at the same time. For output type, select Illuminance. Select the image size to set the resolution of the rendering. For this rendering, choose Medium. Next, set the illuminance and rendering settings. In the Location/Time Settings tab, select the date and time to be used in the rendering. Choose today's date at 11 a.m. The analysis will use your model's location, so you will not need to set the location here. In the Sky Model Settings tab, select one of the 6 different sky models for the illumination rendering and set the sun's intensity, the irradiance if needed. For this rendering, choose Perez All, Weather Sky. In the Legend Settings tab, set the units, the scale range, and the scale increment. For the units, select foot candles or lux. In this rendering, choose foot candles. For the scale range, specify the minimum and maximum values to be displayed in the rendering. Select Automatic to set the scale's range to the minimum value and maximum value calculated in the simulation with 10 proportional subdivisions. For the scale increment, select logarithmic to visually distinguish between values in the lower portion of the range while still capturing very high values. Now we're ready to start the rendering process. Select Start Rendering. If a message appears indicating that some rendering appearances are missing, click OK. This will not matter for our illuminance rendering. After a while, Revit will notify you when your images are ready with a pop-up window on the Revit screen and by email if you selected that option. When the rendering is complete, you can view it in the Render Gallery web interface. Click the View tab and select Render Gallery to view and download your completed renderings online. To access the renderings, you'll need to sign in to your A360 account. Click on the completed illuminance rendering to view it. Note that the illuminance level on each of the surfaces is indicated by the color legend at the side of the image. To download the rendering, right-click on the image and select Save As in the pop-up menu.
So this is how you can set your things accordingly, as well as you can check what are the intensities of energy which you are going to get within a building, or what's the range of those values accordingly, and how to utilize them within the design process. We have done this as well. And so here's a similar video for it. So So there were certain like advanced settings that needs to be prefigured, like which controls your energy model behavior, which runs on the different simulations, and as well as give you both the conceptual masses and elements accordingly. So you need to set up those target energy settings accordingly. What should be the energy settings? So this is what we are going to see in last 5 minutes, and how to have generate a energy model out of it, and how to send it back to Insight for developing the data accordingly to optimize them onto your designs. Right. So here's a small video for it. So we'll do those things directly. So the very first option we would be going on to is analyze option. Then I will just be showcasing you one of the things that we have discovered. And here we have the energy settings. So whether depending on the model type, it is like it has the conceptual masses and building elements, so you can select them. If only building elements, you can go with that option. Or if you only need to generate the analysis for conceptual masses, you can select it accordingly. Right, so depending on the type which has been integrated, you can choose those things and then go on to the other options for further settings for the advanced settings for the energy, where you will have a target hit component, target glazing, that is what wall ratios you need to keep with respect to openings, right? Just opposite of it, what openings need to be caters with respect to the wall ratios. So you can check all those aspects here. Right, so here's a small video with respect to Insight as well. So that's the first part where we are going to develop an energy model. So once by choosing those energy models, then we can prefix what elements need to have an needs to run analysis with. Then you can filter those elements options as well. Once the energy model is being generated, it would be popped out to you onto your project browsers as well as onto your schedules with certain analytical spaces. And you can see there are certain cards which are applicable with Autodesk Insight, where you can check what will be the optimum utilization for those particular aspects, like lighting efficiency or your openings, your shadings, likewise. So you can develop all those sort of factors by choosing and can then input them onto your designs to optimize the energy efficiencies. So all those datas which are there within a BIM model will get integrated directly onto this platform. So then you can extract them in a form of summary as well onto the report format. Right, so we'll just showcase this part onto main Revit part. So yeah, so the similar way aspects is like we have the other 5 tabs that has been activated under the energy optimization parts, right? So here we have to set the energy settings first, then we have to create an energy model out of it, then we have to generate an analysis out of it. So just doing this process and will take you directly onto Autodesk Insight for viewing how the card works or how we can optimize those energies onto our building aspects. Just by choosing this, so whether it has in building elements, you can go with that. Building massing and elements, both of them, which should be your ground plane, and other settings, then I will be going by its advanced settings. So by default, the target percentage glazing is 40. You can also specify the locations accordingly, right? So this is all what we can do over here. By rooms and spaces, you can define if you have it onto the architectural models. So you can do that as well. So once this has been done, you have to just move on to your create energy model optimizations. So once this is done, it will create for the building elements likewise, because right now in this model, I don't think so we have these spaces accordingly. So this is how your energy model is being created. And if you come over here onto 3D views, you will find this analytical spaces, as well as this would be applicable to you onto your schedules as well. Right, so once done, so we can move on for the generating an energy analytical model inside at the inside. So this is the process. It will take certain time and will give you a notification on your mail directly. And then you can see this option for optimizing, which will take you to directly onto the Insight platform. So I will just open my mail for a while. I was having one of the analysis here. So if I type Insight, yeah, so I can view this model directly onto Insight platform. So this is the energy that the building is consuming or taking up. So that's this much in USD per part for the very same building that we were discussing about. And then you have certain cards with respect to it, and you can also make comparisons onto the main home tab. So like if I just flip this, you can see this is for the window shadings that are on the south aspects. Then over here, you can filter it accordingly. What would be the best part to deal with, right? So these are like certain cards which will help you in looking at the aspects to that would be initially helpful for your designing aspects. Likewise, there are a number of cards to look for, and this is how it will give you an data in forms of more uh, specified and strategic way of looking at the designs and what are the cost impacts onto the design. So you can check those things as well. Yeah. So this is it from our end. If anyone is having any questions, feel free to ask. We'll be taking certain questions from Q&A there. So from Mohit, it was one of the questions. Can we use the Revit model directly to do energy and daylight analysis? Yes, you can, but that directly inbuilt instance, it is not inbuilt within a platform. For this, you need to go on to manage.autodesk.com, and then you can install those particular plugins from there, which will get directly incorporated with your interface of Revit, I would say. Yeah. So one of the question is like from Mohammed Shoaib, conceptual modeling can also be done in Revit with sunpath analysis. Then how format is different or can say has an edge when we talk about Revit in similar manner. So format is something which works on very conceptual phase, like it's just a modeling tool, right? It has certain inbuilt additions that comes with it, is like it has uh, certain other features which gives you this shadow analysis. So those are also the part which has been integrated on format. So both of them has those capabilities inbuilt. And as well, I would say like for format, it is similar to SketchUp. You just have the 2D drawings, you can embed those 2D drawings and can develop a 3D out of it. It won't give you those energy it would just have an lighting optimization, which also depends on your location you are setting. So it has those same features. It's not different. Features has been embedded in both of the platforms and gives the same sort of results, but those two of them are very different tools to work with. One is where in Revit you can work from conceptual to its execution phase, but with particularly format, you can only play with forms and certain aspects of analysis. You cannot go with detailed designing, which or any sort of documentation. So those are different capabilities of two different solutions, I would say. I hope that answers to your question. And so one more question is there, like cloud rendering is free or it needs to pay any amount? Definitely, there is a flex token that needs to be purchased, but onto the certain aspects like which is related to its quality and furthermore perseverance. So in that case, you cannot do those things without your flex tokens. So that's something you need to purchase or you need to pay for. Yeah, this is it. So thank you guys for attending this webinar. Hope this would have been insightful for all of you. Yeah, thank you.